Chapter 3 Electrochemistry 3.3 Electrolytic Cell Part 3. By the end of this Part 3 lecture, students should be able to state Faraday's law of electrolysis, apply Faraday's law in calculation, set up electrolytic cell and determine the Faraday's constant. Faraday's first law of electrolysis. In an electrolysis, the quantity of a substance formed is directly proportional to the quantity of the electric charge supplied. M is directly proportional to Q. Since Q is equals to IT, substituting that, M is now directly proportional to IT, where M is mass of the substance, Q is the electric charge in coulombs, I is the current in ampere, and T is the time in seconds. Note, 1 coulomb is the amount of charge that passes when an electric current of 1 ampere flows for 1 second. Students should also know that 1 Faraday is the charge carried by 1 mole of electrons. 1 Faraday is also equals to 96,500 coulomb per mole. Take the reduction of zinc 2 plus for example. Zinc 2 plus produced 2 mole of electrons to produce zinc metal. So to deposit 1 mole of zinc solid from 1 mole of zinc 2 plus aqueous, it requires 2 mole of electrons, or 2 Faraday of charges, or 2 times 96,500 coulomb of charges. The following shows an example of calculation solved using Faraday's first law. In order to solve this question, first step that students need to do is to calculate the amount of charge that flows through the electrolysis. Using Q equals to IT, I being the amount of current flows, T the time taken, and remember it has to be in the unit of seconds, Q is equals to 2700 coulomb, or convert to Faraday 0.02798. From the reduction that happened at cathode, 1 mole of copper 2 plus releases 2 mole of electrons to produce 1 mole of copper solid. Therefore, when 0.02798 Faraday was used, it produced 0.01399 mole of copper solid. Multiplying by the molar mass of copper, the mass of copper deposited is obtained. End of Chapter 3, 3.3 Electrolytic Cell Part 3.